reaching out and touching the sun, it kind of seems impossible, doesn't it?
Well, in a way, the Parker Solar Probe has sort of done just that.
Yeah, and you've probably heard about the sun, obviously.
Of course.
But today,
Yeah.
we're going to do a deep dive into how this probe got closer to the sun than we ever thought possible.
Right.
And what that means for us back here on Earth.
You know what? It's especially amazing when you think about how the idea of solar wind, which is something the Parker Solar Probe is looking at,
Right.
was only first thought up back in the 1950s
Wow.
by a physicist named Eugene Parker,
Oh, wow.
who fittingly the probe is named after.
That's right. It's amazing to think that just a few decades ago,
Yeah.
we were still trying to figure out like the basics of how the sun affects our solar system.
Absolutely.
So for our listener out there, can you break down exactly what solar wind is
Sure.
and why it matters?
Yeah. So solar wind is this constant stream of charged particles
Okay.
or plasma flowing out from the sun in every direction. So think about it like a super powerful, invisible wind that just blows across the whole solar system.
Wow.
And believe it or not, this wind can interact with planets,
Really?
causing things like the aurora borealis here on Earth.
Oh, wow. That's fascinating.
Yeah.
So the Parker Solar Probe is named after the guy who discovered solar wind
Right.
and is studying it up close.
Up close and personal.
How close did it actually get?
5 solar diameters away.
Mm-hmm.
That's about 3.8 million miles.
Whoa. Okay, so putting that into perspective,
Yeah.
if the sun were like a basketball,
Okay.
the probe got as close as someone holding it at arm's length.
That's right.
Wow, okay.
Pretty close.
That is incredibly close.
It is.
I can't even imagine the kind of engineering
Yeah.
that goes into making a spacecraft
Yeah.
that can just withstand that heat
Oh, yeah.
and radiation. Did they have to, like, invent completely new materials to make this happen?
Oh, absolutely.
Wow.
But one of the key innovations is the probe's heat shield, which is made of a special carbon composite material. And carbon has an incredibly high melting point, making it the perfect thing to protect the probe's very sensitive instruments from that intense heat.
Yeah.
And remember, this heat isn't just from the sun's surface.
No.
Where the probe is actually flying through the sun's outer atmosphere.
Right.
The corona,
Yeah.
which is even hotter.
Wait, the corona is hotter than the surface? How is that even possible?
Right.
I always thought the surface was the hottest part.
It's a question that has puzzled scientists for decades.
Really?
Yeah. The corona reaches temperatures of millions of degrees,
Wow.
while the surface is only around 10,000 degrees.
Oh, wow. So it's like...
Yeah, it's like if you had a fire
Uh-huh.
where the flames are hotter than the wood that's burning.
Yeah, okay. That's crazy.
It is.
So what are, like, I don't know,
Yeah.
what are the leading theories about why the corona is so much hotter?
So there are a few different ideas out there. One theory involves these tiny little explosive events called nanoflares.
Nanoflares.
And they're constantly happening in the corona.
Okay.
Another theory focuses on these waves of energy called Alfvén waves,
Okay.
which travel along the sun's magnetic field lines
Right.
and deposit their energy into the corona.
Okay, so these waves are, like, crashing into the corona
Sort of, yeah.
and heating it up.
Exactly.
Wow. Okay, so it's still kind of a mystery then.
It is a bit of a mystery.
But the Parker Solar Probe is gathering data that could help us finally crack this puzzle, right?
Exactly. The probe has all these instruments on it,
Okay.
specifically designed to study the corona's magnetic field and the particles that make up the solar wind.
Okay.
And that data is giving us unprecedented insights into what heats the corona.
This is already blowing my mind.
Yeah.
And we haven't even talked about the speed this thing is traveling at yet.
Oh, you're right about that.
Right.
We haven't even gotten to the speed. The Parker Solar Probe has reached speeds of over 430,000 miles per hour.
Whoa. Okay, hold on.
Yeah.
That's fast enough to travel from New York to Los Angeles in like a minute.
About a minute, yeah.
Wow.
It's fast.
That speed is almost unimaginable.
It's hard to even picture it.
What kind of technological breakthroughs made that possible?
Well, it's a combination of things.
Okay.
The probe uses a powerful rocket,
Okay.
gravity assist from Venus,
Oh, wow.
and careful trajectory planning
Uh-huh.
to achieve these insane speeds.
So it's not just about brute force then. It's about finesse and using the laws of physics to our advantage.
Exactly. It's a testament to all those engineers and scientists
Yeah.
who designed this mission.
Yeah, and all their ingenuity.
Absolutely.
I can't wait to hear more about what this probe has uncovered.
Yeah.
What are some of the key findings that have surprised scientists so far?
Well, one of the most surprising things they found
Okay.
is the detection of these strange zigzag structures in the solar wind called switchbacks.
Switchbacks.
Switchbacks, yeah.
What are those?
Imagine you're looking at the flow of the solar wind, right?
Okay.
It's going along.
Yeah.
And suddenly it makes a sharp turn, almost like a hairpin turn.
Oh, wow.
And then just as suddenly it flips back to its original direction.
That's so strange.
It's bizarre.
And what causes that?
Well, we're still trying to figure that out.
Okay.
But it could have something to do with the sun's magnetic field lines
Okay.
and how they interact with the solar wind.
Okay, so we've got these switchbacks happening in the solar wind.
Yeah.
We're still trying to understand them. But
Yeah.
why should we care about something that's happening millions of miles away?
Here's why it matters.
Okay.
Understanding these switchbacks could actually help us better predict space weather events here on Earth.
Oh, okay.
They might be linked to the formation of those powerful solar flares
Right.
and coronal mass ejections we talked about earlier.
Yeah.
The ones that could disrupt our technology and even pose a threat to astronauts.
Yeah. Yeah, that's right. It's amazing how these things that seem so small scale on the sun
Right.
can have such a huge impact on us. It's like,
It's like the butterfly effect,
yeah,
but on a cosmic scale.
exactly.
Yeah.
So this mission isn't just about scientific curiosity then.
Uh,
It's about understanding the sun so we can protect ourselves from its
yeah.
sometimes harmful effects.
Exactly. And that's what makes this mission so fascinating important.
You know, it's funny.
Yeah.
When we think about space exploration,
Mm-hmm.
we often think about distant galaxies
Right.
or the search for other planets.
Yeah.
But this mission really kind of reminds us that there's still so much to discover right here
Absolutely.
in our own solar system.
Yeah. You've hit on a crucial point.
Yeah.
The sun is the most important thing in our solar system for life on Earth.
Yeah.
Yet we've only just begun to understand its complexities.
Wow.
The Parker Solar Probe is helping us fill in those gaps.
And speaking of complexities,
Yeah.
the sun's magnetic field is something I find particularly fascinating.
Oh, for sure.
It's not as straightforward as you might think.
Absolutely. It's incredibly dynamic,
Yeah.
constantly changing and influencing the behavior of solar wind and other things.
Right.
And what's really remarkable is that the Parker Solar Probe has actually flown through the sun's corona,
Wow.
which lets it directly measure the magnetic field in that region.
Wow. Flying through the corona.
Yeah,
That sounds incredibly risky.
it is very risky.
Yeah.
But the data they're gathering from these daring maneuvers is so valuable.
Okay.
We're learning about things like magnetic reconnection, which is where magnetic field lines break and reconnect, releasing huge amounts of energy.
Can we pause for a second?
Sure.
For our listener out there.
Yeah.
Can you explain magnetic reconnection in a way that makes sense? What's actually happening and why does it release so much energy?
Okay, imagine you have two magnets
Right. Yep.
and you try to push their poles together.
Yeah.
They're going to resist each other.
It's going to push away from each other.
Exactly. That's because their magnetic field lines are repelling each other.
Okay.
But sometimes those field lines can break and reconnect in a different way.
Okay.
It's like snapping a rubber band and releasing all that pent-up energy.
Oh, okay. So it's like a subtle release of tension in the magnetic field.
Exactly.
And that's what causes those powerful solar flares we hear about.
Solar flares are sudden bursts of energy
Right.
caused by magnetic reconnection,
Okay.
and they can have serious effects on Earth, disrupting radio communications and even causing power outages.
It really makes you realize just how interconnected we are with the sun, even though it's millions of miles away.
Exactly. The sun is the ultimate source of energy for this planet.
Right.
It drives our weather, climate, and even the very existence of life.
But as we've seen, it can also be a bit unpredictable
It can,
and even dangerous at times.
for sure.
Right.
Yeah, that's why missions like the Parker Solar Probe are so important.
Yeah.
By studying the sun up close,
Yeah.
we can understand its behavior better,
Yeah.
predict potential threats,
Uh-huh.
and ultimately protect ourselves from those sometimes harmful effects.
We've covered a lot of ground in this first part of our deep dive,
We have.
but there's still so much more to explore.
Absolutely. We've only just begun to uncover the sun's secrets.
One of the things that fascinates me about the sun's magnetic field is how it shapes the solar wind.
Right.
You know, it's not just this constant steady stream.
No, it's not.
We were talking about those switchbacks earlier.
Yeah, those crazy
Those
switchbacks.
sudden turns in the solar wind.
Yeah.
Are those caused by the sun's magnetic field too?
Yeah, that's one of the leading theories. The sun's magnetic field lines are so complex,
Yeah.
constantly twisting and turning.
Uh-huh.
As the solar wind flows along these lines,
Yeah.
it can get caught up in those twists and turns,
Okay.
which causes those sudden changes in direction.
So it's like the solar wind is following some cosmic roller coaster.
It kind of is.
With loops and dips.
Yeah, that's a great analogy.
Created by the sun's magnetic field.
Yeah.
Wow.
And the Parker Solar Probe,
Uh-huh.
by getting closer than anything else,
Yeah.
is giving us a front row seat
Wow.
to this incredible show.
That's amazing.
It is.
So we've got this super fast solar wind being
Yeah.
shaped by this constantly changing magnetic field.
It's wild.
What kind of information is the Parker Solar Probe collecting to help us understand all this?
So the probe has all these scientific instruments
Okay.
that measure all kinds of properties of the solar wind,
Like what?
like its speed, its density, temperature, even its composition.
Wow.
It can also measure the sun's magnetic field directly.
So it's like a high-tech weather station
Yeah, exactly.
right there in the middle of the solar wind.
That's a great way to think about it.
That's awesome.
And all this data is beamed right back to Earth,
Okay.
giving scientists a view of how the sun works like we've never seen before.
That's so cool.
Yeah, it really is.
What are some of the most surprising discoveries that have come out of this data so far?
Okay, well,
Besides the switchbacks, of course.
besides the switchbacks, right?
Yeah.
One really fascinating finding has been these dust-free zones around the sun.
Wait, dust-free zones?
Dust-free zones.
I thought space was like full of dust.
You'd think so, right?
Yeah.
But near the sun,
Uh-huh.
that intense heat actually vaporizes any dust particles
Oh.
that get too close,
Okay.
creating these clear zones
Ah.
that give us an even better view of the sun's surface.
So it's like the sun has its own cleaning system.
That's a good way to put it.
Wow, that's really interesting.
Yeah.
Are these dust-free zones important?
Yeah, they're not just interesting to look at.
Okay.
They can actually tell us about how stars and planetary systems form.
How so?
Well, when a star forms,
Uh-huh.
it's surrounded by a disk of gas and dust, right?
Right.
That dust clumps together and eventually forms planets.
Okay.
But if there are these dust-free zones around young stars,
Yeah.
it could change how those planets form
Okay.
and what they're made of.
So these dust-free zones could help us understand how our own solar system formed.
Exactly.
Billions of years ago.
That's right.
Wow.
And the Parker Solar Probe is giving us our first real look at these zones, which could completely change how we think about planet formation.
This mission is really incredible.
It
It seems
is.
like every time we look at the data,
Yeah,
there's new mysteries and new clues to solve the old ones.
absolutely.
It's really making me think differently about the sun.
Yeah, me too.
I'm sure our listeners too.
I hope so.
It's challenging all our assumptions about how it works and pushing the boundaries of what we thought was possible with space exploration.
For sure.
But it's not just about breaking records and stuff.
No.
There are practical reasons for all this research too.
Oh, absolutely.
Right.
Remember, the sun's activity
Yeah.
can directly impact Earth.
Right.
You know, solar flares and coronal mass ejections, they can disrupt satellites, communication systems,
Yeah.
even power grids.
We were talking about that earlier.
Right.
And the more we understand the sun,
Uh-huh.
the better we can predict
Yeah.
those events
Yeah.
and prepare for them.
Exactly. The Parker Solar Probe is giving us the data we need
Okay.
to improve our space weather forecasts,
Uh-huh.
which will help us protect all that important stuff
Yeah.
from the sun's sometimes destructive forces.
So it's not just about expanding our knowledge of the universe.
Right.
It's also about protecting life here on Earth.
Exactly. That's why this mission is so important,
Yeah.
not just for scientists, but for everyone.
Yeah, for everyone.
It reminds us that we're all connected to the sun
Wow.
in ways we're only beginning to understand.
It's a very humbling thought.
It is.
This giant ball of plasma millions of miles away
Yeah.
holds the key to our past, present, and future.
It really does.
And the Parker Solar Probe is letting us look inside.
Like never before.
It sounds like we're really just getting started with what we can learn
We are, yeah.
from this probe.
Yeah.
What else can we expect to learn in the coming years?
Well, the most exciting thing is that the Parker Solar Probe is still getting closer to the sun.
Really?
Yeah. Its orbit will take it closer and closer each time it goes around,
Wow.
which means we're going to get even more detailed data in the future.
So the best is yet to come.
Absolutely. We're entering a new era of solar science.
Wow.
And the Parker Solar Probe is leading the charge.
This has been an awesome deep dive so far.
It has been.
But before we wrap up,
Yeah.
I want to talk about the people behind this mission.
Oh, for sure.
This is a monumental achievement. Made possible by so many people's hard work and dedication.
Right. It's easy to get caught up in all the technical stuff and the discoveries, but we can't forget about the human ingenuity
Yeah.
and the perseverance that made all this possible.
Absolutely. There's a whole team of brilliant scientists and engineers
Yeah.
who poured their hearts into this project.
That's right.
Not to mention everyone who supported them.
Absolutely.
And it's not just the people involved in the mission either.
No,
Think about all the people being inspired by this.
that's right.
Students who dream of becoming scientists.
Yeah.
The public who is amazed by the images.
Yeah, it's amazing.
And data coming back from the sun.
It is.
It's a reminder that science isn't just about cold, hard facts.
No, it's not.
It's about human curiosity, the desire to understand the universe,
Yeah.
our drive to push the limits of what's possible.
Absolutely. It's about the shared experience
Yeah.
of exploration and discovery.
Yeah, I love that. And the Parker Solar Probe is like the perfect example
It is. Yeah.
of what we can do when we all work together.
Absolutely.
We've been getting pretty cozy with the sun this whole time, thanks to the Parker Solar Probe.
Yeah, it's been an interesting journey.
It really has. We've learned about the solar wind and the corona
Right.
and that super powerful magnetic field.
Wow.
But I'm ready for some more of those like ha-ha moments, you know?
Okay. Yeah.
The stuff that really makes you think.
Uh-huh.
Those discoveries that have the scientists confused.
Okay, I think I have something you'll like.
Lay it on me.
One of the most surprising findings has been these rogue plasma waves.
Rogue plasma waves. Okay, I've never even heard of those.
They're super powerful bursts of energy moving through the solar wind.
Okay.
They're so strong, they actually warp the magnetic field.
Whoa, hold on. Warping the magnetic field. What does that even look like?
Okay, so imagine like a calm pond, right?
Okay.
And suddenly a speedboat goes through.
Yeah.
And it makes this wave that disrupts the surface.
Yeah.
These waves are like those speedboats, creating disturbances in the magnetic field as they go through the solar wind.
Okay, so what's causing these plasma wave speedboats then?
That's a good question.
Yeah.
We're still working on that.
Okay.
But one idea
Yeah.
is that they're generated by those switchbacks.
The switchbacks.
Yeah, remember those sudden turns?
Yeah.
Well, those abrupt changes could be making shock waves
Oh, wow.
that generate these rogue waves.
So it's like a chain reaction.
Kinda, yeah.
Starting with the switchbacks.
Yeah.
And then leading to these rogue waves that mess with the magnetic field.
Exactly.
Okay, so do these waves affect us here on Earth?
Well, potentially they could.
How so?
They might actually contribute to the heating of the corona.
Oh, right.
Yeah, remember how we said the corona is hotter than the surface?
Right.
These waves could be one of the things moving energy from inside the sun
Uh-huh.
out to the corona.
So they're like tiny little packets of energy zipping through space,
Yeah,
superheating the corona along the way.
that's one way to think about it.
That's incredible.
It is.
Something so small can have such a huge impact.
Yeah, and it gets even more interesting.
Oh, okay.
These rogue waves might also be influencing those solar energetic particles.
Okay, the SCs.
Yeah, the SEVs. You got it.
And those are the ones that can be dangerous to astronauts
Right.
and spacecraft, right?
Exactly.
Yeah.
And if we can understand how they're accelerated,
Yeah.
it could help us predict the risks for space missions.
That's a really good point.
Yeah, so these rogue waves are pretty important.
Yeah, they are. It's like we thought we understood the sun,
Uh-huh.
but every time we look closer,
Yeah,
we find something totally new.
absolutely. And
Yeah.
the Parker Solar Probe
Yeah.
is letting us do that faster than ever before.
So we've talked about a lot of crazy stuff in this deep dive.
We have.
As we wrap up, what's the one thing you want our listener to remember?
About the Parker Solar Probe.
Yeah.
I think the biggest takeaway is that the sun is more dynamic.
Okay.
And more complex
Yeah.
than we ever imagined.
Wow.
It's constantly changing.
Yeah.
And influencing everything around it.
Yeah.
The Parker Solar Probe is giving us a front row seat
It really is.
to all of this, revealing secrets that have been hidden for billions of years.
Oh, wow. That's amazing.
And the best part is that we're just getting started.
Yeah. It's like we've opened a door to a whole new understanding of the universe.
I like that.
And we're just starting to explore what's on the other side.
Exactly.
This has been an awesome journey, and I can't wait to see what other discoveries are out there waiting for us
Me too.
as the Parker Solar Probe continues its mission to touch the sun.
It's going to be exciting.
It really is.